Dear students, good morning, good afternoon, good evening. How are you? I hope best for you. I Mukesh Kumar welcomes you to online Mukesh Online Academy. आपका मुकेश ऑनलाइन एकेडमी में स्वागत है and we are doing the science of class 10 from the NCERT book and that is a chapter number 13 we are doing magnetic effect of current. Okay. Any board which is following the NCERT curriculum, okay, the students from that board can benefit from these videos. Okay, and we have already covered this chapter into the previous 9 videos in which we covered about the introduction, what are the different type of magnets, what are the directing and properties, attracting properties of the magnets. We did about the magnetic field lines, we did the activities, okay, and we did the magnetic field due to the current carrying conductor, straight conductor, okay, coil and solenoid. In the last video we did about the solenoid. Okay, I hope you would have seen those videos. If you have not still seen, I have given the links into the description. It is better you go those videos before watching this video, okay, because every video is in continuation of it. And one usual tip, just take out your notebook and pen, okay, make the summary, write the key points. Okay, whenever you are watching video, any study related video, you should develop a habit of writing the key points. Okay, it helps you to revise into the exam and in the same time you are just keeping in your mind also. Okay, and when you make the summary, it becomes very easy to revise into the exams, and I hope you must be doing that. Okay, and if you have any query, if you have any doubt, you can write to me on the WhatsApp or email, so we will be happy to solve your queries. Okay, and you can get the notes free of cost of all the chapters. Okay, just write to me on the WhatsApp or email, so we will be happy to provide you, okay, along with the practice questions. And I hope you must be getting knowledge from my video, you must be getting benefited from my videos. Kindly share it with your friends, subscribe to it and ask your friend to subscribe. And what we are going to do in this video about the electromagnets. Okay, how does an electromagnet work, what are the different uses of electromagnets, that what are the different factors on which an electromagnet depends. So that we will study into this video, and what is the difference between a permanent magnet and a electromagnet and which is better. So now let's do it. So now let's do the electromagnet. Electromagnet means, in the last video we had studied about the solenoid. So solenoid, and till now we have studied that whenever we flow or whenever the electric current is flowing through a wire, means the copper wire, then it behaves like a magnet. Okay, so we studied about the straight current carrying conductor, then we studied about the coil, and then we studied about the solenoid. Solenoid has got the many coils. Okay, so the electromagnet is an extension of the solenoid. Okay, so you can convert the solenoid into the electromagnet also by just putting a iron bar into that. When we put a iron bar into the solenoid, then it becomes a electromagnet. Electromagnet means whenever the electric current is flowing through it, that means it will remain the magnet, and whenever we switch off the electric current, then it no longer remains a magnet. So that is why electro means electricity, magnet means magnet. So it is becoming the magnet whenever the electricity is flowing through it. Okay, so now let's write it. An electromagnet is a magnet consisting of a long coil of insulated copper wire wrapped around a soft iron core that is magnetized only when electric current is passed through the coil. Okay, so this we have studied that long coil of insulated wire. Okay, just like a solenoid, but what is the difference? In solenoid there may be or may not be a soft iron core, but it is always wrapped around a soft iron core. Suppose this is the soft iron, it is always wrapped around a soft iron core, then it becomes a, then it is a part of the electromagnet. Okay, and it will magnet only when current is flowing through this coil. Okay, and suppose if we put the iron core inside a solenoid, then also the electromagnet can be prepared. Okay, it can also be prepared by placing a soft iron core in a solid. Okay, and it is a temporary magnet. I told you it will remain as magnet as long as the current is flowing, so that is why we call it a temporary magnet. Okay, it is a temporary magnet. Okay, it shows magnetic properties only as long as electric current flows through the solenoid. Okay, now if we switch off the current, then electromagnetism or the magnetism will no longer remain. Okay, if we switch off the current in the solenoid, it no more behaves as a magnet. All the magnetism of the soft iron core disappears as soon as the current is switched off. Now, so when we are putting the soft iron core into the solenoid, then and current flows through it, then it becomes a magnet, because the soft iron core also get magnetized. So the magnetism becomes too much and it becomes a stronger magnet. Now the question comes, why do we use the soft iron core? Because the soft iron core has the low retentive properties. Okay, it will easily get magnetized and easily will get demagnetized also. It does not retain the magnetism. Okay, so that is why we use the soft iron core here. Okay, soft iron core is used for making the core of electromagnet, because it can be magnetized and demagnetized easily. Okay, when the current is switched on, it gets magnetized easily. Okay, and when the current is switched off, it gets demagnetized easily. Okay, so this is the reason that we use the iron core as a soft iron as a core of the electromagnet. Okay, now then why don't we use the steel? Basically, steel has got the high retentive power. So when it gets magnetized, see, it will take time to get magnetized also, and once it gets magnetized, it will be difficult to lose its magnetism because it has got the very high retentive power. So that is why we do not use the steel as a core of the electromagnet. Steel has got high retentivity. When it is magnetized, it requires to be placed in a very strong magnetic field. That means slowly it will take time to get magnetized. Okay, when current is switched off, due to its high retentivity, it does not lose its magnetism and hence becomes a permanent magnet. Okay, so steel is not used for making electromagnet. I hope this is clear to you. So why don't we use the steel? Why do we use the only soft iron core? Okay, now they can be in the different shape and sizes. Okay, depending on the usage that we want to get in. Okay, it can be bar type also and it can be U shape also. Electromagnets can be made in different shapes and sizes depending on the purpose for which they are to be used. Okay, as you can see from this diagram, this is the soft iron core. Okay, and this is the coil. Basically this is the solenoid, or means this the wire has been wrapped around a soft iron core and it is in the rectangular form, so that is why it is known as the bar type. So this shape is the bar type shape. Okay, now you can see that this shape is the U shape. Okay, or we call it the horseshoe type also. Why do we call it horseshoe type? Because this type of shoe is fitted in the leg of the horse. Okay, so that is why it is also called the horseshoe type, or you can call it the U type. Here this U type is the iron core. Okay, this is the soft iron core on which this copper wire is just folding. Okay, there is a loop of the copper wire. Okay, this copper wire is wrapped around this U-shaped iron core. That is why we call this the horseshoe type or the U-shaped magnet. So we can have the different type of the electromagnet, and their sizes can be different, and because of the different needs. Okay, where do we need them? According to our need, we can make the size and the shape. Okay, now let's repeat it. See, electromagnet is magnet consisting of a long insulated copper wire around a soft iron core that is magnetized only when the current is passed through the coil. Okay, clear? So whenever we just wrap the copper wire around a soft iron core, then current is passing through it, then it becomes a electromagnet. Or what we can do, we can just put the soft iron core into the solenoid, and then it also will behave like a electromagnet. Okay, and it is a temporary magnet. It will show magnetic properties only as long as the electric current is flowing through the solenoid. Once we switch on the current, then it will behave like a magnet. Once we switch off the current, then it will no longer remain the magnet. Okay, and we use the soft iron core for making the core of the electromagnet. Reason, because the soft iron core can be easily magnetized. Okay, once the switched in on, it is easily magnetized, and it can be easily demagnetized also. That means when the current is switched off, it loses its all magnetism. Okay, and becomes a normal iron. We do not use the steel as a core of the electromagnet. Why? Because the steel has got the high retentivity. First of all, it needs to be placed into a very high magnetic field to get magnetized. Okay, so and it will magnetize very slowly. And since it has got the very high retentive power, so when we switch off the current, then it will not lose its magnetism, and it will become a permanent magnet. So that is why we do not use the steel as a bar magnet. And we can make the electromagnets into the different shapes and sizes depending on the use. Okay, so whatever the use we want, we can have the whatever the shape we want, according to our need we can make. So this is the bar type because the rectangular iron bar is there, and on that insulated copper wire is wrapped. And this is the U-shaped type or horseshoe type because the soft iron core is in the form of the U shape. Okay, so both kind of magnet can be used according to their size and use according in the different sizes according to the use. I hope this is clear to you. Now, as you can see here it is a north pole is given, here the south pole is given, same here north pole is given, same here the south pole is given. So, how do we find the polarity of the electromagnet? We find the polarity of the electromagnet in the same way in which we find the polarity of a solenoid. That means we will use the clock face rule here. Okay, and we already know what is the clock face rule. If the current is in the clockwise direction, means facing it in clockwise direction, that means it will be a south pole, then the other pole will be the north pole. Okay, if it is facing in the anti-clockwise direction, then it will be a north pole and other will be a south pole. So we will use the clock face rule here to find the polarity of the electromagnet. Now let's write it. Polarity of an electromagnet can be determined by using clock face rule. Okay, so what does this clock face rule says? That if we view electromagnet from the left end in this particular diagram. I am talking about this particular diagram. Okay, it can be different in different diagrams. Okay, the current is flowing anti-clock. Okay, so that means it is a north. Okay, now the other pole will become the south pole. If we view electromagnet from the right end in this diagram, I am talking about in this diagram only. Okay, the current is flowing clockwise, so that means it is a south. Okay, so the clock face rule we have used particularly only for this diagram, and if the pattern of the current changes, then these poles will also change. So you have to see the diagram carefully and decide which way it is going the current, and then you can decide which will be the north pole and which will be the south pole. And here we are talking about this particular diagram. Okay, now as we study into the solenoid, there are some factors which affect the magnetism in the solenoid. So same way, there are some factors which will affect the magnetism or the magnetic property of the electromagnet. So what are these? Number one, we had studied the current. The same here. If we increase the current, then the magnetism will increase. If we decrease the current, the electromagnet will be less strong. Okay, that means magnetism decrease means it will be less strong. Second is the number of turns. Same way as we had learned into the solenoid. If we increase the number of turns for the same length, then we have like a more stronger magnet. And if we decrease the number of turns, then we have like a less strong magnet. It means the magnetism will be reduced. And the nature of the core material, it depends on the nature of core material also. If we use the soft iron core, then it will be magnetized and demagnetized easily also. Okay. And then air gap between the poles. Here you can see the air gap in the bar type between the north and south pole is more, distance is more, so it will have the lesser magnetic field. Here in the horseshoe type, you can say there is a less air gap between the south and north, so it will be a stronger magnet. So generally the horseshoe magnets are used as a electromagnets because they are much stronger than the bar type. So now let's write it. Factors affecting the strength of electromagnet. Okay, number one, strength of current in coil. Okay, means more current, stronger the magnet. Okay, if we change the current, then accordingly the electromagnetism will be changed. If we just decrease the current, reduce the current, then it will be less strong, means its magnetism will reduce. And if we increase the current, then its magnetism will increase. Okay. And number two, the number of turns in the coil. As we have studied into the solenoid also, if we increase the number of turns, then the electromagnetism it will become a stronger magnet. Okay. Larger the number of turns, greater the strength of electromagnet. Okay. And number three, nature of core material. And nature of core material we have already discussed. So we have to take the soft iron core because it gets magnetized and demagnetized in itself very easily, and depends on the length also. Okay. And the fourth, we have the air gap between the poles. Okay. If there is a large gap between the north and south pole, then it will be a less stronger magnet. If there is a small gap, then it will be a very strong magnet. Okay. The smaller the gap between the poles, stronger the field produced by electromagnet. Okay. So now let's compare which one will be the stronger. Okay. The air gap between the poles of bar type electromagnet is quite large, so it is not very strong. Okay, the air gap between the poles of U shape, or you can say horseshoe type electromagnet is small, so it is very strong magnet. Okay, I hope this is clear to you. So that means if there are same number of turns, the same nature of core material and the same strength, then the U shape magnet will be much stronger than a bar type magnet. Okay, so for the same material, same core material, same current and same number of turns, okay, a U shape magnet shows higher magnetic field than a bar. Okay, I hope this is clear to you. Now let's repeat it. So what are the different factors which affect the electromagnet? First is the strength of the current in the coil. Okay, stronger will be a current. If we increase the current, then the electromagnetism will increase. Okay, number of turns in the coil, if we increase the number of turns, then again also the greater will be the strength of the electromagnet. So that means normally the commercial electromagnets are made with many number of copper turns. Okay, nature of the core material. Okay, if we use the soft iron core, then it will be very good. Okay, and air gap between the poles. If there is a large gap between the poles, then it will be a less stronger. If there is a less gap, then it will be a much stronger. So in the bar type, the gap between the poles is much more, and in the U shape, the gap between the poles is less. So the horseshoe type is a stronger magnet than a bar type. So if we take the two magnets, one bar type, other horseshoe type, having the same current is passing same through both of them, have the same number of turns, have the same core material, that means the U shape will show the more magnetism than the bar type. I hope this is clear to you. Now we will study the uses of electromagnet. Now the next topic is uses of electromagnet. See, they have got wide variety of uses. Okay, like in the scrap yards, to remove the iron from the scrap, it is used because it is very convenient. If we take the permanent magnet, then the iron will get stuck to it and will be difficult to remove. So we use the electromagnet, because when the current is switched on, becomes a magnet, the iron will stick to it, and then at the separate place we will just switch off the current, then iron will remove from it. So it will be very easy to segregate the iron scrap from the other kind of scrap. Okay, and it is also used for lifting the heavy loads, like in shipping industries. Okay, in shipping industries, if we use the string type cranes, then it will be difficult to balance it, so they use the electromagnet type of cranes. Okay, so now number one, for lifting and transporting heavy loads of large masses of iron in steel works and scrap yard. Okay, number two, in medical practice, it is also used to remove the iron particles or any bullet from the body. Okay, because it is stronger, so it will just take away the iron from the body. Okay, it will just suck that. In medical practice of removing pieces of iron from wounds. Okay, and number three, it is used in the electric generators, it is used in the fans, it is used in many electric devices. Okay, to make the more stronger magnetic field. Okay, in electric devices such as electric bell, electric fan, telegraph, electric trains, electric motors, electric generators, etc. Okay, so here also the electromagnet is used. Clear? So what are the different uses of electromagnet? Let's repeat. For lifting and transporting heavy loads of large masses of iron in steel works and scrap yards, in medical practice of removing pieces iron from the wounds, and electric devices such as electric bell, electric fan, telegraph, electric train, electric motors, electric generators. There are so many uses. Okay, I hope this is clear to you. Now we will just see which type of magnet is better, whether it is a bar type, which is a permanent type, or whether it is a electromagnet. So we have to just check whether the electromagnet is better or the permanent type of magnet is better. Okay, so let's write the difference between bar magnet, or we can say the permanent magnet, and electromagnet. Okay, so serial number, we will write electromagnet here, and we will write bar magnet, which is a permanent. Don't confuse it with the bar type electromagnet. We are taking wire magnet, which is a permanent magnet. Okay, as we know that electromagnets are temporary magnets because they lose the magnetism when the current is stopped, and they gain the magnetism when the current is on. Okay, and here this is permanent. Once we make the bar type magnet, it becomes permanent. Okay, the second point we have, can be easily magnetized and demagnetized. Means we have already learned, okay, clear, कि when we switch on the current, it magnetizes very easily, and when we switch off the current, it demagnetizes easily. Here cannot be easily demagnetized. Okay, it does not lose its magnetism very easily. The third point is its strength can be varied or changed by changing the current through it, or by changing the number of turns, or both. Okay, but here cannot be changed. It is permanent. That is why we call it permanent. Okay, that is why the electromagnets are the stronger magnets also, because we can make much stronger than the bar magnet. And the fourth point is very strong magnets. They are comparatively weak magnets. Okay, here we can reverse. Suppose if we have somewhere the magnet's fixed position and we want to change the polarity. So in bar magnet we cannot change the polarity once it is fixed. Okay, we have to just change the position. But in electromagnet, by just changing the terminals of the battery, we can reverse its polarity. Okay, so the polarity can be reversed by changing the direction of current in the coil. Here cannot be changed. Means fixed polarity is there. Okay, so now let's repeat them. Electromagnets are temporary magnets. They are the permanent magnets. We can magnetize and demagnetize them very easily, but it cannot be easily demagnetized. We can change its strength either by changing the current or by changing the number of turns, but we cannot change it. Once the magnetism is given, it will remain in that value. So they are the very strong magnets. They are comparatively weaker magnets. We can reverse their polarity. Means north and south pole can be reversed by just changing the direction of current. Here we have to change the entire magnet. We have to change to reverse the polarity. So that means here polarity cannot be reversed. I hope this is clear to you. So based on this discussion, what we can conclude that a electromagnet is much better than the bar magnet. Okay. So now let's write the conclusion that an electromagnet is better than permanent magnet. Reason: it can produce a strong magnetic field, very strong magnetic field, and its strength can be controlled by varying the number of turns in the coil or by changing the current. Okay, I hope this is clear to you. So students, today we have studied what an electromagnet is. Okay, what are the different uses, how do we find the polarity of the electromagnet, and what are the different factors that affect the electromagnet, and what is the difference between a permanent type of magnet and the electromagnet, and which is better, electromagnet or permanent magnet. I hope this is clear to you. So dear students, in the next video we will cover the questions on the topics covered till now. We have covered the straight current carrying conductor, coil, electromagnet and the solenoid. So in this video we will cover the different questions, okay, on these topics. Okay, thank you so much for your watching. Write your comments about the video, any query, any doubt about the topic into the comment box, or you can write to me on the WhatsApp or email. And I hope you must be getting knowledge from my videos, and I hope you must be making the key points also. Okay, kindly share it with your friends, subscribe to it, ask your friend to subscribe. Thank you so much.